So this is what we have. This is the problem that we have. You know, there is a song by Mick Jagger. You can't always have what you want, but if you try, you might find that you get what you need. Problems like this remind me of that song. And it's kind of typical to college algebra. This is kind of a complication that kicks in with college algebra. And that is that until college algebra, you had a word problem, you set up unknowns, you solved equations. And once you found the solution of the equation, you became suddenly all-knowing, like you knew everything. That stops. There's going to be situations where you cannot find everything. You can just barely find the one thing that you're asked. And this is a first example for that. And when you're stumped with a problem, sometimes it's nice to start with what we have. And then when you get stuck, work backwards. Okay, so what do we need? There is also something strange about this problem is that this circle, this little circle in the big quadrant circle, doesn't seem to be interacting with the big circle a great deal. Yeah, this horizontal line is a tangent line to the little circle, and so is this horizontal one, but otherwise there is not much going on between the big circle and the little circle, and that's kind of interesting. So what I do in situations like this, I introduce capital R and little r because they're kind of intuitive. Capital R would be the radius of the bigger circle of whose quadrant we're looking at, and little r would be the radius of the smaller circle. But I'm already tempted to draw in this line, indeed. So let's see what we need. So what we need to find is the area of the region. I'm trying not to shade too dark. It's basically whatever is inside the quadrant, the quarter circle, but outside of this circle. And that should be a subtraction. So we're going to take the area of the quarter, which is 1/4 of the full circle, minus, oh, we know that this is 6. Okay, so I want to factor out not just pi, but pi over 4. Just mentally write this as 4 pi over 4. So if you factor out pi over 4, we're going to get r squared minus 4r squared. If you're not sure, just multiply it back. Basically, we just write 4 over 4 here. Pi over 4 times r squared, that's there. And pi over 4 times 4r squared, the 4 cancels, there is your pi r squared. So this is what we need. Basically, this is what we need. Now let's see what we have. So it's going to take you for a while to come up with even one equations. First, we're looking for 2, right? We need 2 equations to solve for the 2 radii, but that's not what's going to happen here. So here is one where the horizontal side is obviously 6. The hypotenuse is clearly the radius. We're talking about this is a radius in the big quadrant circle, so that's r. And it might take you a little work to discover that this is a diameter in the smaller circle, twice little r. And then we just state the Pythagorean theorem for this right triangle and get that 6 squared plus 2 little r squared equals to r squared. So 36 plus 4r squared equals to r squared. And then you might be looking for a long, long time for another equation, but there isn't. What we have instead is 36 equals to r squared minus 4r squared, which is exactly the stuff we need, right? So basically, no, we don't know capital R, we don't know little r, but we know that this distance happens to be, this difference happens to be 36. So what we need is pi over 4 times 36, or 9 pi. Now, how could we tell that this is what's going? We can't tell it for sure, but one thing you can do is, well, maybe we cannot solve for capital R and little r because they are not uniquely determined by this problem. What if we grew the quadrant circle? If we grew this quadrant circle, then that line, that 6, that might have to be pushed up to remain 6 long, and that might make this smaller circle bigger. So in other words, the big quadrants, the big quarter circle and a little circle grow together, which is not a surprise. The surprise is that they grow together in such a way that this expression remains constant, which is what the problem is about. But you can use these geometric arguments to see that maybe we cannot find capital R and little r because they are not uniquely determined by the conditions stated in the problem, which is exactly what's the case. And again, just so you know, you're going to see a lot of this starting with college algebra. Thank you for watching.